So this is interactive video number 7 for lesson task 7. Now in your lesson task, it is covering 7.1, 7.2, 7.3. However, I'm not going to touch much on 7.3 and 7.1 because the skill is mainly covered in 7.2 that I want to address. So here is the skill type of problems I expect. Let's say I have a problem like -3 cosine, -3 cosine of x, and then +4 sine of x. And I want you to express in terms of some k sine of x plus phi. Let's say I want you to turn this expression in terms of k sine of x plus phi, for phi some angle measurement. So with this problem, the reason why I'm talking about this for the interactive video is because all the other stuff is pretty much, hey, can you use this formula, work backwards or work forwards, plug in these values? This is a bit different. I want you guys to actually understand the process and how the proof was derived. So instead of looking at your book and seeing the formula for k sine of x plus phi, I want you to derive it every single time. There's no purpose in just copying and paste that, in my opinion. So, what do I mean by that? Well, we know that this right here is relating to the sum of sines. It's just backwards. The backwards version of sum of sines. So, if I want to go to the sum of sines backwards, I need something in the form of sine of x cosine of phi and plus sine. So this is what I need. And then it's a sine of, I guess I'll keep it consistent with the way your book has rated it down. Cosine of x, sine of phi. They alternate. That's the idea. They alternate. So I need this right here. I need this expression. Now, in this problem, it might be better if I reverse this. Remember, we can revert, we can, commute. It is perfectly fine. So I can just turn this into cosine of x. Let's use this theorem instead because that's more helpful, or this statement. Let me change some ordering around. As long as I keep the terms together, it should be fine. Over here. So I have this. Let me rearrange this piece too. Let's put sine phi first, then cosine x. And I put this in this order so we can see the relationship. So I need this piece right here. I'm giving you this original expression, and I want you to convert it to this piece, but I need this to invoke the sum of sines. To invoke that theorem or property or identity, I need this kind of expression. Well, if you look at our problem, we have a cosine of x. We have that. It's right here. We have a sine of x. Boom. All I'm missing is a sine of phi and a cosine of phi. But that's the location of where -3 and 4 should be located at. So, to invoke the sum of sines, what we're going to do is set these coefficients equal to those terms. We're going to set -3 is equal to sine of phi and 4 is equal to cosine of phi. Boom. We need to do that. Now, there should be some issues already. First of all, these phis need to be the exact same. That's the first issue. They might not, they could. We have to verify it. The second thing is, these values are bigger or less than -1 and +1. So it should be undefined if I try to use my inverse function to solve for the angle. It should be undefined. So there's an issue with this. In this problem right here, we're actually not on the unit circle. We're not on the unit circle at all. We have this triangle or this circle with bigger radius than 1. But I do know if I had this phi measurement, that opposite is -3 And that adjacent is for on the unit circle, if you think about it like that. However, it's not on the unit circle, so I have to extend that. I have to increase that. I have to figure out what my new radius, new hypotenuse is. How do I figure out the hypotenuse? A squared plus b squared equals c squared. So this has to be 5. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. Square root that. That'll give you that 25. That's how we want to get the process. So we need to set this all over 5, all over 5. That's our opposite over hypotenuse, and that's our adjacent over hypotenuse. Now, if you try to do it over 1, that is perfectly fine, but then you'll get a triangle similar, but you won't get the right values out. So you need to start thinking about, hey, does this lie on a unit circle or does it not? All right. So I have these angles. Now I need to apply the inverse function to solve for them. So I'm going to apply sine inverse of phi, negative 3 over 5, and then I'm going to do cosine of inverse of 4 over 5. What angle measurements do I get? Well, let's just check that. Let's use a dandy software. Let's go to Desmos. Let's just do that. Sine inverse of negative 3 divided by 5. And I need to make sure I'm in degrees mode, because I want the degree measurement. And cosine of inverse of 4 divided by 5. Now, I've stated that the angle measurement, the phi angle measurement, have to be the same. Why are they not the same? Well, this is a problem that we've constructed. Remember this, when we worked with inverse function, we chose to cut off pieces just to make our function nice. In reality, when we do problems, the inverse does exist, but it might not be a function. So we have to account all those other values. It makes no sense to actually use the inverse function. It makes more sense to apply the inverse, if that makes any sense. I don't want to just restrict all my results. I want to see all the possibilities that the angle measurement could be and choose the correct one, not the one that would make the function nice to play with. So how do I even select it? Well, going back to our original problem, we have our sine value negative, our cosine value positive. That should give you an insight. If I am on a unit circle or in a quadrant, now it's not a unit circle, the y value is negative, the x value is positive. So this means it's in this quadrant over here, quadrant 4. The y value negative, y negative, x positive. So how do you know which one is the correct one? We know our angle lives in the 4th quadrant because sine is negative, cosine is positive. Well, looking at these angle measurements, 36.869 is in the 2nd quadrant. However, negative 36.869 is in the 4th quadrant, so this actually does work. So we want this angle measurement that's in the 4th quadrant. That means I can rewrite my entire expression as 5, which is our k value, hypotenuse slash radius, sine of x plus negative 36.869 degrees. All right, that's what our function or our expression is equivalent to. And it's important you make sure you know the distinction, because let's verify this with the graphing calculator. If I want to verify that, I can type in f of x, a function with respect to x variable, and now I'm going to use variable x. Find sine of x plus negative 36.86989. I'm just giving you a bunch of decimals to give the idea. This is what our function looks like. Now, if I want to graph the original function, go up here, it's all the way at the top, right there. This original problem, let's graph that into a new function. Let's call that g. Let's still use x. And g says we have negative 3, I believe, and negative 3 cosine of x plus 4 sine of x. Notice that the function is on the exact same location. It might be off by a few decimals, but you can't even see that. just because we rounded it up. But they are the exact same. Now, what if instead I wanted to use positive? Will that be different? Notice the functions are not the same anymore. So even though you calculate the inverse correctly, and these are the proper range outputs for inverse functions, the real world doesn't work as nice, or these problems aren't as nice where we have to use the inverse function. We just need to generalize it to use the inverse property, not necessarily the inverse function property. There's a difference. Inverse function only has one solution, only one output for one unique input, or one unique output for one input. Whereas the actual inverse property is just swapping inputs and outputs. So I have infinite amounts of angles that are possible. So you need to figure out which ones are correct, and you can verify with the graphing calculator with this. So we've figured out how to do this, so that is the important skill that I require in 7.2. 7.3 have some of this, but not necessarily. It's more so, hey, do you know these identities? Can you work backwards, forwards, all that? So as long as you're doing that, that's fine. That is it for today. I will catch you guys later. Take care. Bye.